Greetings, people of cyberspace. Meat space possibly too. Welcome to this long-awaited follow-up to the Wellington Harbour curvature test. I'd planned to test the curvature between Wellington's west coast and Kapiti Island, but I found out that to do it properly I'd have to get up really early to get the right light. After weeks of trying to work up the gumption for an early start, something occurred to me. I remembered a local legend I'd heard a while back, but dismissed as nonsense. Rumour has it that on a clear day, with everything in the sky just right, you can see all the way to the South Island, and that's much further and much bigger than wee Kapiti Island. So I decided to take a drive around the Wellington coast with my camera and a couple of lenses to test this legend out. I'm going to show each place I drive to in Google Earth and take a few photos so you know it all checks out. So here we are zooming into Orfido Bay. First stop is that's the closest point in Wellington to the South Island that can be accessed with a regular vehicle. And those mountains, I think, are the South Island. Let's see if we can see them through the camera. Yeah, that looks to be a mountain over there. And through my telephoto lens, my god, it's the South Island. It's a pretty big mountain, that one. I wonder how far away it is. We'll check that out later. Now off to Island Bay, the west side of Island Bay. Very imaginatively named by the conquering Europeans, who the Māori called Pakeha, which translates roughly to white pigs. Very apt, but I will say this, the Māori did a whole lot better than most indigenous cultures. The dirty Pakeha didn't know what they got themselves in for when they came to New Zealand. And I think that's the same mountains over there. And yeah, I got my trusty compass just so you guys know I'm not lying. And look, I even got footage, a panorama of our lovely southern coast. And there's that mountain again. And my photo of the mountain. And off we go to the east side of Island Bay. The Māori called that island Tapu Te Ranga, and it's said to be patua, which is kind of like sacred. Okay, that looks to be those same mountains again, and it's my picture of them. A scenic spot, Island Bay, and it's the ferry going to the South Island. Okay, now across the harbour to Days Bay. Just crossing over Soms Island here, our local leper colony. Every good city's got one. It's got to contain those lepers. Here we are, the Days Bay Wharf. And yep, that looks to be the same mountains behind the peninsula there. And this was completely on purpose, left the camera on just so you guys know that I am actually at the jetty. Completely on purpose. And my trusty compass pointing to that same mountain by the look of it. Let's go check out these mountains. Okay, zooming out and over the South Island. They're a bit further away than I thought. Yeah, that's quite a distance. That's 93 and 81 miles. I had no idea they were that far. Okay, I found this on the web. It's to help measure curvature, and it takes into account the height above sea level that you're measuring from. As you can see, 12 feet, that corresponds to the height on the jetty that I took these photos. Wow, so from the Days Bay Wharf, Manukau should be obscured up to 1604 metres, so that only leaves 1,000 metres that we should be seeing, but it seems we can see pretty much all the way down to sea level. That's a whole mile which should be obscured by the horizon. I don't think we're seeing that. Let's go back to those first shots we took at Orfido Bay, because one of those has got a perfect profile, missing the mountain to the right a little bit, but we should be able to figure out what's what. Check this out. I'll end the video with this. Make up your own mind. Hey, welcome to another edition of the CBS World News. I think this is number 10. Today's video is going to be about the Sun and its supposed distance from the Earth. We've all been told since we've been too young to know better that the Sun is 96 million miles or 150,000 kilometers away from the Earth. I think most of us, before we were well through the process of indoctrination, must have noticed those pesky crepuscular rays that come out of the clouds, which basically point to a common origin, making it look like the Sun is a whole lot closer than we were told. Now, that's been explained away as an optical illusion. Maybe the refraction of light as it hits the clouds causes them to beam out, or some people say they're actually parallel, it's just a trick of perspective. I guess most people would buy that, but I've found something that pretty much puts the nail in the coffin for that theory and seems to prove that the Sun is a whole lot closer. I've been looking at some time-lapse footage of flights, and I've found this one from Mauritius to Frankfurt. See if you can spot anything wrong with this footage. Okay, I'll slow this bit down here and repeat it a couple of times. Are you noticing that? Basically, you can draw a line straight from the Sun through the clouds to their shadow on the ground. And I'm talking any cloud. So that's not a trick of perspective, because the convergence point is not the horizon, it's the Sun. So basically we're triangulating the Sun with its shadows going through the clouds. So, you know, if we knew the distances, we could work out exactly how large and how high the Sun is. It's been done. So this proves that crepuscular rays aren't just a trick of light, a local aberration, because we have physical evidence on the ground, the shadows of the clouds, which prove that the Sun is a whole lot closer than we've been told. Now look at this footage I found, it's almost too good to be true. Okay, swinging around we can see the Sun, and he's just going down through the clouds for a landing. Can't see anything, blurred out. Crepuscular rays pointing right at the Sun. Check that out. If there was any doubts, crepuscular rays are just light bending and bullshit like that. Nah. YouTubers, fellow skeptics who aren't afraid to look behind the facade, even you poor scared people who choose to cling on to a lifetime of conditioning and indoctrination. You've probably seen a few curvature test videos by now, maybe even my Wellington Harbour curvature tests. Basically, people all over the world have been taking pictures of mountains, buildings, islands, etc., which, assuming that we live on a globe as we've been taught, should not be visible. Or not be visible all the way down to sea level as shown here. Those still clinging to outdated models will insist that it's all an illusion, a mirage. Quite literally. They maintain that light is bent due to differences in air temperature, shifting objects which should be hidden under the horizon into view. They'll say that this effect is most evident when looking over bodies of water, due to water changing the temperature of the air closest to the surface. So, according to the current model that we've all been taught all our lives, images like these are just an illusion. Obviously, we can't trust our senses. I was thinking, if that was so, we should be seeing some kind of spherical distortion, however minor, due to the fact that the light must curve around a ball. Not only that, photos taken of the same distant object should differ vastly when taken at different times of the day and year due to temperature difference between the water and the atmosphere. To test this, I've gone out and taken some more photos of the southern mountains and the Kaikoura ranges from roughly the same spot, mostly the west side of Owhiro Bay. I've cobbled them together into panoramas in Photoshop just so we've got the maximum possible resolution to work with. This should give us a decent range of conditions, so according to the ballers, we should be seeing a different image, or some differences in these images. So let's have a look. What I'm doing is comparing the mountain line on each photo, and well, it's looking pretty damn similar. Same proportions, other than the fact that some of the photos are taken from different places, so we've got slightly different angles on the mountains, but overall that's looking suspiciously like I'm getting exactly the same optical image of the mountains each time, as in the light comes at me straight, we're seeing the same mountains in the background, the same proportions. What else can I conclude? But the earth is flat, there's nothing else for it. You'd have to have some pretty severe cognitive dissonance at this point to actually believe that that is caused by refraction, light bending because of temperature differences. It's quite frankly ridiculous. Like, did you see that? So I have to show it again. I will. Have another look at this and get past that cognitive dissonance, people. Like, it's flat. Hello fellow YouTubers out there reveling in the cyberspace matrix. Not too bad as far as matrices go, or is that matrices? I don't know, that's irrelevant. Anyway, in my last video I tried to prove that the sun is a whole lot closer than we've been told by showing the shadows of clouds on the ground and crepuscular rays which seem to converge right at the sun as opposed to coming in the atmosphere parallel like. It can be hard to get your head around this sort of thing, and a lot of people probably think this is just a trick of perspective. So to disprove that, I've set up a simulation in After Effects. I've attempted to make a similar scene, and first I'll show you how the shadows of the clouds look with a near sun. Watch what happens as I slowly raise it. As you can see, when the sun gets higher, the shadows of the clouds seem to slowly converge. So let's see what happens when I switch the light to one that's more like the sun, as it's been explained to us. After Effects has the option to make a parallel light source. So, as the sun is supposedly 96 million miles away, 155 million Ks, it's pretty much parallel. As you can see, when I draw lines from the shadows on the ground through to the clouds, they kind of diverge or converge at the bottom. So as I expected, the simulator with the close sun seems to be a much better representation of what we actually see in the sky. And with the sun simulation making parallel rays, as we should be getting from a sun 96 million miles away, the shadows do not match up with the reality we can witness with our own two eyes. So how far away did they tell us the sun is again? Because you know what? I've got to call bullshit.
Hello YouTube, faithful subscribers, whether you're boosting my ego with positive comments or you're keeping me on my toes with some intelligent trolling, you're all appreciated. Despite the fact that I've already proved flat out that curvature of the Earth can't be measured, and that is not due to any kind of atmospheric refraction, light bending. And despite the fact that I've devised a definitive curvature test using multiple reference points to prove that the Earth is flat, I often hear that it can't be proven either way, whether the Earth is round or flat. So I'm going to take the flatness test a few steps further and go into a bit more detail to prove once and for all that we're living on a plane. I'm going to stick to using photos of the Kaikoura Ranges in the South Island of New Zealand, taken from Wellington's south coast. This gives us a pretty decent range in terms of point-to-point length, as well as a decent range in heights of peaks that we can use. I've been out there a few times taking panoramas, as the spot's just breathtaking, especially at sunset. On the day I was out taking these shots, the conditions were just about perfect. The further away the mountains are from the camera, the lighter they are. That's because there's more atmosphere between us and the further mountains, so they get kind of washed out. Pretty obvious, but this photo demonstrates it nicely. I'm going to pick out a few prominent peaks and color code them for convenience. And now go to Google Earth and find them. and a few weeks later I've found them. It's pretty hard work, but I'm confident that I have found the right ones. But please don't take my word for it, check for yourself. Everything you need is right here. Once again, I'm going to enter the heights of the peaks and the distance from the camera into a graph. Now I go back to the photo and make a horizontal line at the height of each peak, color coded of course. Since the furthest mountain away is also the tallest, I can just cut it at that point, and where that line meets each other point gives us an extrapolation to a 2D view to count for perspective. So hopefully it'll match up to the lines on the photo again. Let's have a look. And once again, pretty much perfect. I'm guessing refraction's not playing much of a part here. I don't think we get a whole lot over the Cook Strait, judging by my experimentation. And what anomalies you can see there, I'm willing to bet would be a result of Google Earth's measurements. We can't expect Google to have accurate data for every nook and cranny in the Kiwi bush. That's some pretty full-on wilderness out there. Now I'm going to do the curvature calculations for each of those peaks and input that into a graph to do a comparison. Let's see how it looks. As I suspected, it's all over the show. Not only does it not match, but some of the lines have crossed over. Any of you ball lovers out there care to explain that to me? I didn't think so. If we get these scales matched up, we can get a rough idea of how it would look if there were any curvature. I'll leave you with that. I'd have to say, curvature thoroughly busted. Once again. Thanks for watching.
Hey, Chubbs here again, back with a quick video. I've been doing a bit of an experiment in 3D software, just trying to figure out how perspective works, particularly the perspective of the sun and the moon, and trying to find out myself if the flat earth model actually works. I'll also be comparing it with the globe earth model to see which works best. It seems like a pretty big stretch that the moon is setting, or the sun is setting below the horizon due to perspective. Like, if that was the case, the moon and the sun would have to get minute compared to the size we usually see it up in the sky, because it's such a long way away from us. And then they say that it just disappears and goes behind the horizon. And yeah, it seems like a bit of a stretch, but I think I've devised a 3D model which can help us see if this is possible. Okay, here's a top-down view of the scene that I've made. What you're seeing here is a camera placed just on the shore of a little bay. You can call this a hill up here or whatever. Not a very high one, but I just put it there to make some sort of a horizon, like a false horizon. Now that's a target camera, so I put the target right below where the moon is here. The target stays still, but the moon moves on a straight trajectory, as you can see, basically above the viewer's head. When I zoom down to the level of sight for the camera, our guy on the shore, it looks like a real scene, so here it is rendered. Let's have a look at this animation. It looks a bit far-fetched. Surely the moon doesn't get that small in the sky. So let's see if we can find some real footage to compare that to. I've made another model in 3D software of the globe model. This time there's a camera just on the surface of the Earth, and we're just looking at the sun rising over the horizon and going out of view of the camera. Obviously the sun doesn't change in size to any perceptible degree in the sky, as being 93 million miles away and 1 million miles wide, and the Earth only about 6,000 miles wide. The Earth turning does not make a difference. It only moves the viewer a maximum of 3,000 miles closer to the sun. During the daytime, that is, where the sun is actually visible in the sky. So let's see if we can find some real footage to compare that to. I wasn't expecting to see that. Let's compare it to my 3D model, side to side. Wow, so after seeing that, it seems pretty obvious which model reality actually fits best. And it's not the globe model we've been taught for 500 years, and wow, all our lives. Man, we've been sucked in.